All right, so this is going to be a lecture on kinetics, and this is kind of an introductory to some of the notes and subjects we're going to talk about. So kinetics, the first thing we need to discuss is what is a rate. So rate is a change occurring within an interval of time. So for chemists, we are looking at a chemical reaction. So this is our reactant. So this is our reactant. This is our product. So as I go from reactant to product, what is happening to that change? Okay, so rate is going to be calculated as what we call delta A over delta T. So delta is the triangle we see here in front of the A. So what we're looking at is how is A changing over a period of time. So T is going to be time. So as we were exploring with the thiosulfate hydrochloric acid lab, we could actually graph what is happening to A over time. So A is going to start at a certain what we call concentration. So I'm going to put concentration on the y-axis, and then I'm going to put time on the x-axis. And time could be in seconds, it could be in minutes, it just depends upon the reaction. So A is starting at a certain concentration. So A is going to be somewhere up here. And over time, it's going to decrease and then kind of level off. Okay, so it's usually a curve. So this is A changing over time. So what you see is reactant is being used up to produce product. So you will see that the concentration of A kind of decreases over time. So because this is a curve, we always try to look at making curves into what we call straight lines. So what I'm going to do is draw another graph down here. And this graph is going to be looking at what is happening to concentration, again in molarity, versus 1 over time. Okay, because essentially rate is change over time. And what we look at mostly as chemists is how is the reactant changing over time. And so since curves are not easy to predict off of, if we look at concentration versus inverse of time, in some reactions, I'm going to get a linear graph. And what we like about linear graphs is I can easily predict at what period of time and what concentration will I have. Well, do note that this is y versus x, and we know slope is y over x. So slope in this case is going to be molarity over the period of time, okay, because this is inverse time. Well, that's essentially rate. Okay, so that is why you will see that graphing that we did with the thiosulfate lab, we got curves and we got straight lines. Okay, but the straight line with our slope, we could get what we call a rate for that reaction. So in going with the idea of rates, how do we know a chemical reaction occurs? Well, what was kind of alluded to in the thiosulfate lab is we have a relationship where we have something called collision theory. Collision theory states that atoms, ions, molecules, whatever it happens to be, can form a chemical bond when they collide, provided they have enough kinetic energy. So the key to this definition is the word collide, because again, it's collision theory. But then we also have something called kinetic energy. Okay. So if I have, again, the hydrochloric acid molecule, and then if I have the sodium thiosulfate molecule, again, I'm just drawing them as circles to make it easier in having a conversation. Okay. In order for this chemical reaction to take place, they needed to collide. And not only did they need to collide, but because they are moving, they have kinetic energy. So both of them have kinetic energy. These are my reactants, okay? in order to make product, they need to interact. Okay, so they have to collide, bonds need to be broken and then reformed. Okay, so then if I look at it according to after the collision, so then this is going in this direction, this is going in that direction. I have produced sulfur and I've produced sulfur dioxide. These are going to be my products. So again, using the sodium thiosulfate example, I have now created products. But in order for this to take place, I need those collisions. And without those collisions, I have no chemical reactions. Now, another thing that was mentioned is what we call orientation of the molecules. We're not going to have too much focus on that in this level of chemistry, but it also has to do with how these molecules are oriented in order for that to be a complete reaction.